Alright, this is my 100 subscriber special. I know it's nothing special, but I still wanted to do something, and this time I will just present to you what I've been up to. So, you might know WPL, and this is the WPL C24-1. And you might not know that it looks like this, because normally it looks more like this. This is the normal WPL body, and I put all the stickers on it and thought to myself, well, you could improve on it. And I started let's say furiously printing out stuff, because I got a 3D printer. So I thought to myself, how can you make this better and better? But before I started printing anything, let's look down here. And you see, I upgraded as many metal parts as possible. I'll use this to show. First of all, metal driveshafts. Those are these that are a bit more movable in many more degrees. And the problem is, well, I have no really special way of going about this video, so I will just talk as I see fit. The first thing you will notice is that these drive shafts have a bit of slack. Then the metal gearbox also has slack. And this drive shaft has slack, and the differentials have slack. And what this equals is that the whole car has this much slack. You will notice it when it moves suddenly forward or backward, that this slack gets a bit noticeable. And maybe you guys know something how to fix that, or if it's even possible to be fixed, or if larger competition crawlers have the same problem. I don't know. I'm kind of new to all this. But stability-wise, everything was thoroughly Loctited. So I don't have any problems anymore with screws randomly falling off. But I had that in the beginning, and this was a huge pain in the ass. The next thing you might notice is in the rear I have, I don't know how you would like to call it. This can either be pushrod suspension or cantilever style suspension, but I tuned it to be lower than the front. This has still enough give, but it's also helping with the climbs. The next thing is the front. I don't know how you would see it best, but in the front I have normal coil over shocks, and they are a bit longer than normally, because I wanted to be higher in the front than in the back, which helps with the approach angle. As you can see, this is nearly 90 degrees. So this thing can climb up slightly higher than itself. So if this bumper in the front catches something, it will slide up. I don't know how I can demonstrate it best. For example, if you have this, if you crash into this with enough speed, this will catch on this sloped bumper, and if the two wheels bite, and these are very supple wheels, this car will climb up. The next thing I have noticed, now from one problem to one janky solution, you see this gearbox here sticks out quite a lot, and it has a hard, sharp corner. And this would get caught every time when you try to climb over something. So, ingenious as I am and cheap, I made a modification with Lego parts. You may be able to see these sliding rails. These are just made out of Legos screwed to the chassis. They are tough, they never broke, and they help the car slide. Next thing you might notice are all the 3D printed parts. Let's just count them all quickly. I have cut out the old flares and put in large bushwhacker flares. Links for all the STL files are in the description. I hope I will remember. We have large bushwhacker style flares in the front. Then we have this whole thing down here. You might be able to see it is a larger, deeper electronics tray. So now I could have the most important part. I have a large 1500 milliamp battery, and I could fit it in the front. And you might know for crawling, the most important thing is to have the weight in the front and not in the back. And this was genius because I could fit the battery in front, the servos in the front, and the electronics just stick out here in the back. But it's not a problem because they are slightly waterproof. And just to be sure, I also packed them in a small bags. This was just these zip tie bags. And the next 3D printed part are these guide rails here, for no specific reason actually. There are no reasons for that because the sliding rail is down here, but it's looking much nicer because if you have this wide of a front, it's nice to have also some white parts in the back to help with the overall design, because otherwise it looked a bit manta ray shapen. So if you don't, if you imagine these rays are not there, it's just a wide, massive front, and then it tapers to a very small and narrow back. And this leads me to my next printed part, this extension here with the rear bumper. It had, I wouldn't say no use. It's not only design, because my problem was if I use it like many people use with the WPL C14s and C24s, they would just have this chassis go only up to here. But when the car starts to climb drastically, it's rather nice to have something like a janky wheelie bar to stop it from completely rolling over. And that was very useful, but it's not overly useful. It's more for the design, because I just couldn't stand how short the car looked. It looked very stumpy. It was just a cabin. Many people like this design. I don't. So I made this extension here. I will also try to give you the link for the STL files for that. It's holding up, but I wouldn't really put too much strain on it. But the thing is, it won't really hit something with much speed from the back, because these things, it's just printed in PLA, they will break. They did break. So it's not for the structural parts. So I left the stock bumper, even though I have some STL files for competition style bumpers to help me climb even better. They are called Stinger bumpers. They go this far up and would help me climb everything, but I tried to print bumpers, and as you can think, this is ABS. PLA bumpers just broke all the time. You couldn't do anything about them because they don't bend, they instantly break. It's not useful for that. This is also the reason why I didn't print this, because this would also just break off. I think I make a small break and show you the internal. So, welcome back to part 2. This time we will have a look at the internals. I will quickly open it up. take too long, and we'll see the whole drivetrain. The cap is just mounted with 4 screws, so I didn't have any problems with that, but I think it's not really enough. I mean, WPL thought of 4 screws because they might be enough for a small crawler, but I upgraded all metal parts. The normal WPL C24 weighs nearly nothing. I didn't really weigh it, but it's not anything. But now that it's full of metal parts, it has quite a bit of heft to it. But this is the drivetrain. I hope you can see everything. These are the larger springs. I put on some heavy springs because if I would use the normal thin springs from the front, this was just sag to the ground. And these are really heavy for the use case I have. So they bend everything a bit, but there are no real shocks or impacts going here because it's just transferred through this lever here. So I don't think this PLA part will break. It didn't, and I don't think it will. But there is quite a bit of force going on here. So I made the cantilever pivot point go all the way through the metal chassis, and the levers here are solid PLA, and I hope they won't break because in this point there will be some shocks, some impacts, but nothing yet. This is the battery I've been talking about. It's just velcroed to the front here. It's actually 2000 milliampere hours, and it's 20C, 7.4 volt, and lithium ion batteries. I will just turn it on quickly that you see one of the bigger problems I have. As you can see much because the standard LEDs I put on that burned out. I didn't think they were meant, but it's the same voltage as the normal WPL battery. This is just larger, but they still burnt out because I think because the control board had a step down regulator in it. But these are rated for 12 volts now. I'm happy they turn on at all. But I don't think they will burn out, and they didn't do yet, but they are very dim and very orange. But it looks the part with the red paint of the car. Looks pretty red and orange and aggressive to me, so it'll be all right. Next thing, you might notice the sponge here. I know I tried to silence the car a bit because you might be able to hear it. I will turn it on quickly. It's not that loud. This is rather silent. The problem is once you put on, I will do it very quickly here, the body. This is a large resonant body, and it's, I don't know if you can really hear it, but it's much more loud and obnoxious. So I tried to counter that with the noise dampening foam here. Didn't do much, to be honest. I don't know why I have it still there, but it doesn't matter. Electronics wise, Dumbo RC, 6-channel controller. Many people are talking about it. It's the best, cheapest controller, and everyone was raving on about it. So why would I choose another? I am new to this, so I will do what most people recommend. And this is the receiver, 6 channels, it's quite a lot, and it can be switched to gyro mode, that the car will correct itself to drive straight forward. But my, first of all, it's not needed for crawling. It's not about going straight, it's about control. And second of all, the gyro mode would require this to be firmly mounted in place so that it doesn't shift around, and I have no mounting places for a receiver this big. Maybe I can put it here, but there's just not enough room, and I don't see a use for it because it works now flawlessly. As you see, it's in little plastic bags to save it, and also in plastic bags is this Esc unit. The problem with this Esc is I don't know what it is. I bought this. I bought the red WPL with. It was a used project, and this was just with it. I didn't have enough money to buy a Esc, and I also didn't know if it would work with the motor. And it did work, but it runs a bit hot. It didn't burn on me yet. The normal, the standard board of the WPL burnt out with this new motor, but this is holding up fine. And the new motor is a Traxxas unit. I just thought, why not have a big ass motor with this gearbox, and it's really pulling. The top speed is rather nice. It's fast, but actually right now I'm missing a bit of torque. It's not a really torquey engine, and this is bad for climbing, so I would rather have a motor with more turns, but these would draw more amps, and then I would need a bigger Esc and the whole shebang. So I would just stay with this right now. The next thing you might notice are these rims. They might not look that awesome. I think they look pretty cool with the bolts and nuts, but these are 3D printed bead lock wheels. Yes, no more gluing. The first wheels I printed were these with the standard kit tires of WPL. But they look really cool. They look even cooler than that. The problem is gluing. I hate gluing. I never do it good enough, and it's just messy. What if I want to clean out the inside of the tires? I can't. I have to rip them apart all the time. So I always were jealous of beadlock tires, beadlock rims, and I couldn't really afford metal beadlock rims. So I thought, wait, you might be able to print them, and there is an STL file for that. So these are 3D printed beadlock rims. I might make a special video about these rims because there's something you have to be careful about. I don't know if they are planned wrong or if I'm doing something wrong, but they are a bit too wide, so they don't really grip the tires tight, and I had to melt them smaller a bit, narrower, so that they fit the tires. I don't know if this was intended or not, but now it works fine. Didn't slip a tire. All going good. Yeah. Let me know if you have any more questions about the car. I will make a driving video soon when the weather is a bit better and show you a bit of its abilities. For a tiny crawler, this is one of the best starter kits you can have. I would still recommend it to everyone, even though when you buy the WPL C24-1, yeah, it's a mouthful. When you buy the kit, it's all plastic, and the first revisions also had plastic gears, and I had to upgrade quite a lot. Got them as birthday presents, all the metal parts, and it's really a capable crawler once you've gone full metal. With the plastic, if you just drive around at home, around your bed or on the couch, it may hold up, but the first thing that instantly broke, it was in the same day, were these truss bridges that mount the links to the axle, they instantly broke off. It's thin ABS plastic, and nobody really talks about it, but I would say this is not good enough even for a cheap set like this. It's just too flimsy. But I will, if you want, I will make a separate review of the WPL C24-1, how it was stock.